Here we go, another day in Unit 4, 4.07, Factors and Rational Roots. You've learned about factors and rational roots, but we're putting different things together today with the ultimate goal being to factor polynomial functions. Okay, so we're going to use that, and we're going to use the rational root theorem to help us. Let's start with the factor theorem. The factor theorem states if you divide a polynomial, let's just call that polynomial function f of x, by a binomial in this form, x minus k, and get a remainder of 0, then that means two things. The binomial is a factor of the function, and also the little number in the box is a root of the function. So this is very helpful stuff. So in other words, if you're asked to divide a function, a polynomial function, by a binomial in the form where x is to the power of 1 plus or minus a constant, and you get a remainder of 0, again, that means two things. It means x plus 3, the divisor, is a factor of this polynomial, and it also means the number in the box, -3, is a root. And that makes sense, right? Because if you set the factor x minus 3 equals to 0 and solve for x, you would get -3. And to help this make even more sense, this is the same concept like dividing 12 by 4. If you take 12 and you divide it by 4, you would say, oh yeah, 4 goes in 3 times, you get a remainder of 0. So 4 is a factor, 4 and 3 are factors of 12, right? 4 times 3 is 12. Same idea. So go ahead, use synthetic division to determine if the binomial x minus 6 is a factor of this polynomial function. Let's see. If this is x minus 6, the number in the box is positive 6. Remember, you take this, set it equal to 0, and solve for x. Do we need placeholders? 3, 2, 1, 0. No, we don't. So 1, -4, -20, and 48. So we bring down the 1, multiply, add, multiply, add, multiply. What is 6 times -8? We get -48. So is that binomial x minus 6 a factor of this polynomial function? It definitely is. Because why? Because the remainder was 0. Okay? All right, let's go ahead and dive a little deeper. We know now that x minus 6 is a factor of the function. We also know 6 is a root because the remainder was 0, but how many more factors and roots are there? Well, you've learned about this before. Do you see it on the board? There's one little, literally little thing on the board that tells you, remember, the highest power of your polynomial tells you how many factors or roots you will have. Remember, there's always the same amount of factors as there are roots because you find factors, set them equal to 0 to then find the roots, right? So there are two more answers, and how do we find them? Interesting. Well, the rational root theorem might be one way, but before we look into that, there's something else interesting I want to show you. You found that x minus 6 is a factor, but whether you realize it or not, you also found what it multiplies with to give you the original function. Do you see it? Well, in a recent lesson, we learned that this answer right here, including the remainder, but the remainder is 0 in this case, this answer here tells you that you have another polynomial, doesn't it? And remember, to know what power this x goes to is 1 less than your original polynomial. So up here it was x to the third, so we start with x squared. Okay? Now, how can we find all of the roots? Because remember, there are 3 of them. Well, this looks strangely familiar, doesn't it? How do we factor a quadratic with a leading coefficient of 1? Hopefully you're thinking X method. Let's set it up and see what we get. Factors of -8, -4 times 2, -2 times 4. You can move things around and see what works. We want it to add to a positive number. So we need a bigger positive number and a smaller negative. And that just so happens to work out. 4 times -2 is -8. 4 plus -2 is 2. So we can rewrite all 3 factors now, just like you see here. So we found the 3 factors we knew that were there. And how do we find the roots? You set this equal to 0 because of the zero product property, which means you need to take each individual factor, set them equal to 0, and solve for x. So we add, we get 6. We subtract, we get 4. And we add, we get 2. And just as a quick refresher, do we remember where these points will be on the graph? These are going to be your x-intercepts, aren't they? That's what your roots are. All right. Now, up until this point, we were given a binomial, right? And we're asked, is this a factor of the function? Just like we were asked here, but you're not always going to be given that information. Believe it or not, this is actually making things a little bit easier for you, because sometimes they're not going to tell you that at all. How do you find out what the roots are? Using the rational root theorem. The rational root theorem says all of the possible roots of a function or equation can be found by all of the combinations of P over Q. What is P and Q? P are all the factors of the constant term, where Q is all the factors of the leading coefficient. And I want to be very clear here. We're talking about the possible roots. They are not guaranteed the roots, but they're a maybe. It's up to us to find out which ones actually are. So let's make this make more sense and put it all together in an actual example. They want you to factor this polynomial completely. So remember, P is all of the factors of the constant term. In this case, it was -8. So you list out all the factors. 1 times 8 is 8. 2 times 4 is 8. And for these factors, you always include the positive and negative case. Now, what about Q? Well, Q is all the factors of the leading coefficient. Leading coefficient here we can see is 1. So how do we write out our possibilities? Remember here we said all possible combinations are P over Q. So we put all of our values of P that we found over all of our values of Q that we found, which just so happened to be 1. Okay? Stick with me now. All of these fractions here are over 1, aren't they? So we can simplify them and just write them like this. Now what we have are all of our possible rational roots. Cool little trick, right? Once you get the hang of it. Now, how many possible rational roots do you see in that box? If you're thinking 4, look closely. What does plus minus mean? Well, that means you have a positive one and a negative one and a positive 2 and so on, right? So there are actually 8 possible rational roots there. So if you were asked to take this polynomial now and actually find those roots, how would you do that? Well, we have 2 options. One way, test each possible root using synthetic division. Well, here we just said there are 8 possible roots. Do you want to use synthetic division 8 times? Personally, I don't. And sometimes there's more possible rational roots, depending on the polynomial. You might have 10 or 12 or however many, right? So I would advise against it. Instead, I would choose this method, which is use synthetic division once to find the first root and then factor to find the rest, just like we did before. We used this method before today, and you're going to see it. So go ahead and try this out for yourself first. And now let's do it together. So you kind of have to start with some trial and error. Pick one of these numbers and see if it works. Let's try positive 2. Okay, do we need placeholders? No, we don't. Let's see what we get. No remainder 0. This one did not work out. Okay, let's try negative 2. So guys, sometimes, yeah, it will take you multiple tries to get it. Sometimes you'll get lucky and get it on the first try. So let's try this again. Look at that. Second try. Not bad, not bad. So now that we found the remainder of 0, that's one thing, but it's another thing to look at it and know how to write out what you found. Can you do that? Well, if negative 2 is a root, then that means x plus 2 was a factor. Do you know what the other factor is? Well, just like before, we have 1x squared, negative 3x, and minus 4. Remember, that comes from here, here, and here. And how did we get x squared? Because it's 1 less than the polynomial than we started with. 1 less degree. Okay, well, that's all good. But how many roots do we actually have? Well, we just said this polynomial is to the 3rd power, so there's 3. So we need to factor this more. Let's do it. We're going to use the x method once again. We have negative 4 and negative 3. Well, I know anything that's added, any factors of 4 that are going to add a negative 3 have to have a difference of 1. So it's only going to, or sorry, a difference of 3. So 4 and 1 are the only numbers that can add to give us negative 3, but it has to be negative. So let's see. Negative 4 times 1 is negative 4. Negative 4 plus 1, negative 3. Got it. So here's our 3 factors. And set it equal to 0 and find your 3 roots. Okay, we already said earlier that negative 2 is a root. You want to set these all equal to 0 and solve for x, but I'm out of space here, so I'm just going to write out the roots, there they are. Can we see how synthetic division is helping us? Can you see how the rational root theorem is helping you? I hope so. And the method we just used is different than this. This would be if you took every possible rational root and used synthetic division. Does this look like a fun time to you? If it does, do it. But if it doesn't, do this. Personally, I think this is easier, especially if we got the rational root right on the first try. If we guessed right on the first try, you would have not even had to do this, and the work would have been even less. So basically, there's less guesswork in this. Okay? But you still get the same answer if you did it right. Our last problem of the day, our exit ticket. Can you find all the zeros of this function? And I'm going to give you some help here. I've already listed out the possible rational roots. Let's see if you got it right. Should have got 1, -5, and 2. We've done this many times, so I'm not going to walk through it again, but check your work. See how you did, make corrections. And that's going to do it for 4.07.